There are many AI systems that will generate a 3D model. In this video, we will look at Copilot 3D. At the moment, it is in the lab section of Copilot and is free to try. Here are some 3D models that Copilot has created. This video will show how Copilot was used to make a 3D model of a simple house. The model took only a few seconds to generate. This video will show the whole process in real time. To generate a model using Copilot 3D, you have to have an image of the object on a plain background. I wanted to make a simple model of a house, so I fed this prompt into Copilot. Create an image of a low-polygon 3D model of a small, two-bedroomed house on a plain background. The image generated was okay, but too much extra detail. I entered the same prompt into Google Gemini, and I got a house I preferred, but it wouldn't remove the wings. So I brought the image into Copilot, and it removed the wings. I now had the image I wanted to make the 3D model. Now to go into Copilot 3D. Click Labs, and up come the experimental systems that are available to try. Find Copilot 3D and click Try Now. Click the Upload Image button. Find your image, select it, and click Open. When your image has uploaded, click the Create button. Copilot 3D feeds the pixels from the image into the AI model. The model is a large network of artificial neurons. Each neuron is connected to many others, and each connection has a weight. The network is trained with a large set of image and corresponding 3D model pairs. The weights are adjusted so that the training data input produces something closer to the training data output. The process is repeated until the model is ready to be tested with new input data, which is what we are doing. We are testing the AI model with our image of the house to see if it can generate a good 3D model. The process is happening in real time as we watch. Here is the generated model. If anything, it is too good. It has too much detail. For games where real-time rendering is required, low polygon count models give higher frame rates. Copilot has a simple 3D viewer, and we can view to model in grayscale or in color. To save the model, click the Download button. The GLB format is suitable for importing into Blender and BabylonJS. To take a closer look at the model, import into a 3D modeling package such as Blender. Open Blender and move the cube to the side. File, Import, and select the GLTF/GLB format. Go to the folder where you downloaded your model, select it, and click Import. Now, to take a closer look, scale the model uniformly. Now change the viewpoint to front, and I am going to move the house up a bit, to roughly ground level. Change the viewport shading to Material Preview. Now change the viewport shading to Wireframe. Straight away, we see a dense mesh of nodes and edges, far denser than the simple cube and much denser than the simple house needs to be. If we go into Edit mode and turn viewport shading to Solid, we can take a closer look at the mesh. We see a fairly dense mesh of triangular faces, the density increasing in areas of greater detail. It all seems fairly random, and there are artifacts, or maybe deliberate blemishes, like a hole in the roof or a chipped tile. Here, the house is uploaded into the BabylonJS game that I have been developing. It may not be the low polygon count model we would ideally want, but the BabylonJS engine renders it at a reasonable frame rate. Typical of AI systems, often what you get is not exactly what you want. Typical of AI systems, it can generate jaw-droppingly good stuff in seconds. Typical of current AI systems, human finishing is often required. For instance, I could take images of the faces of the simple house and UV map them to a really low polygon count mesh. It gives me something to work with. I hope this video has been interesting. Thanks for watching, and goodbye.